Welcome to the second part of this tutorial series. In this video, we're gonna add some frosting to our donut. If you haven't seen the first part where we make the dough of the donut, you should check that out first. So let's jump right in and make some frosting. Okay, so how do we put some frosting on here using geometry nodes? Well, first of all, I'm going to copy my donut, Shift D. Now I have another donut. I'm going to call it hello frosting. Cool. Now this guy also has the O geometry nodes on it. So we have the same donut, which is a good starting point with the screw modifier. This is good. I'm gonna do a displace in geometry nodes now, just because I said it before. Let's figure out how we do it. So I'm getting rid of the displace. I do need the screw modifier. So I'm gonna also hide my dough. So now I'm only looking at frosting. It doesn't look like frosting yet. Maybe we should start here. Remove the dough, give a new material, call it frosting. Of course it needs to be pink, right? Pink, like that. And roughness, maybe turn down a little and give it clear coat with a little bit of roughness so that it's very, very shiny, sugary material. Cool, so this is frosting. Here we have the O modifier. Now underneath the screw modifier here, we're gonna add another geometry nodes modifier, and this is going to be frosting. So in our frosting geometry nodes, first of all we are going to maybe deform this thing a little bit. So we're gonna do geometry transform. I want to scale it out on the X and the Y, make it a little wider, so like 1.2, maybe that's a lot, I don't know. Yeah, that's gonna be a lot, 1.05, just a little bit. And I want to squish it on the C just a little bit, 0.9. So this is what it looks like. Okay, dough, hide the dough. Cool. Now we're gonna do displace, like I said. So this is just to squish it. Now here we're gonna build a displacement. For displacement, we can use a texture from the textures tab over here. My startup file has some textures in here already. We're just gonna create a new one. So we're gonna click here, call this frosting displace. Okay, it should be a cloud. That's fine. Not sure about the size yet. What if we turn this to? I don't know. We're gonna have to see. So what do we do in here? We need an attribute sample texture, and we're going to sample our frosting displace. The mapping. Now this is where you plug in a UV map, but we're generating our donut shape. It doesn't have a UV map. It's generated out of a circle that's rotated. There's no UV map on here. So for the mapping, we're just going to use position. So the position of each vertex here mapped basically onto a UV map. And the result should go into something that we can call, well, let's call it bump. Oh, it's not bump, it's displace. So displace, let's call it displace. Now this gives us values between 0 and 1, right? This clouds is like 0 is black, 1 is white. So we're definitely gonna need an attribute math node to take down the strength a little. So we're going to multiply the displace with a float. I have no idea, 0.3. Put that back into the displace. And then we want to displace along the normal. So we're gonna need another attribute math node, multiply an attribute, the normal, where is it? Here. Gonna multiply the normal with an attribute which is our displace, and we can put that into a let's call it normal displace attribute. And now we can move our vertices along this normal displace So we need another attribute math node. No, actually we need a attribute vector math node. Oh, you know what? This should be a vector attribute math also. So again, normal displays, put it into something called normal displays. Okay, so we can get rid of this guy. This is where we multiply our normal vector, which is always of length 1, with our factor, which is coming from that texture. And now we have a new position vector. Now we have to do attribute vector math. We have to add to the position our normal displays and put that back into the position. And then we have this horrible looking thing. Wow. Let me see. Attribute math, multiply the displays with a factor. This should be multiply, okay. So now we have this, and we can use that to just offset or displace it a little bit. I think we want to go negative to inflate it a little. So now here we can see the displacement, and here we can see that this is probably too big. So if we scale that up a little, we get more bumps like that. Also, one thing might be that we don't have enough geometry here. Let's see, where, switch on wireframe. Oh, that doesn't help that much. So this looks like a little bit low poly. Maybe that's the look you want to go for. So now we recreated a displace modifier in geometry nodes. So if you think of a displace modifier, let me go to the dough here where we have the displace. You plug in a texture, which is what we do in geometry nodes, and then you have the strength, and you're displacing along the normal, right? Same thing on the frosting now. We're plugging in the texture. This is the strength value here. And then we're moving the vertices along the normal. So this is it. Cool. We have frosting now. The entire donut is frosted. And so now it is this actually inflates the donut quite a bit. So our displacement not only modifies, it also inflates. Okay, so we're gonna need a little bit of a helper here to bring it back down, otherwise this is gonna get too big. Let me add a a layout frame here and put all of these in here. You guys go in here too. And we can call this a frame. This is this place. Cool. So, well, this is just a little bit of a transform displace. And then now in here, I want to shrink it back down a little just to have the possibility to do that. So we're gonna need an attribute vector again, attribute vector math node. What do we want? We want to multiply the normal with a certain factor, which is going to be a vector, and the result should be the deflate parameter. And then we need an attribute vector set to add, and we're gonna add to the position this attribute, which is called deflate. Whoopsie, deflate. Plug that into position. So now here we should be able to inflate and deflate. Yep. Cool, so now we can bring it back down a little just so that it's bigger than the donut. Okay. Now maybe we don't even need this node, I don't know. What? We have all sorts of factors now that we can play with. And of course we want the frosting to be on top here, right? So this is deflate. How about I create another layout frame and put those two into, put those into that frame. Call the frame deflate. Cool. And now I want to move that whole geometry up a little, so I take a geometry transform right at the end here, and I'm gonna move this guy up so that the frosting sits on top of the donut. It's gonna be quite thick frosting. So this is going to be pink diabetes. Awesome, that's what I'm gonna call this. This is art. Cool. Now we have to play with these things here a little bit. Maybe we're deflating too much or not enough. I have no idea. Play with this, play with this. This is giving us that little bump effect, which I think looks pretty cool. Cool. So, displace, deflate, and then we're just moving it up so that it's sitting on top. It's already starting a little bit to look like a donut. Now, if we don't have enough geometry in here, coming from our O and then the screw modifier, we can always add a geometry, a mesh subdivide node right at the beginning here. And then you can see we have a higher poly count here, more details. Now over here we have a bit of an issue because we have displacement on the dough and we have displacement on the frosting. So now this is just a matter of tweaking things. Let's see, what if we go to this texture here, or maybe go to the modifier, bring the strength down a little bit so that no, I like the displace here. Maybe even bring that up. So we have a very lumpy donut. Type soft. Oh, what is type hard? Does that look good? Let me hide the frosting. Well, that looks like dough. You know, the trick to realism, I mean, I'm not going for realism here, but the trick is to make it look as lumpy and imperfect as you can. So this is what that looks like. Okay, cool. I think I liked the soft better. Okay, back to the frosting. Frosting is on top and the dough is shining through. Maybe the frosting displace here is a bit much. So if we turn this down a little bit, maybe even a little more. Doesn't have to be that lumpy, right? So this looks kind of cool. We could probably bring this out a little more. The X and Y. And then it looks like this. And we still have the donut shining through, so we have to move everything up some more, like that. Now this is a really thick cover of frosting. Okay, so this is already pretty interesting. Now, I did spend some time before when I tried to do this, and there is one step that takes a lot of time in geometry nodes, and that is to make it look like it's drooping down on the sides a little. I'm just gonna show you how I did it or how you can do this, and it's all math based. It's really not that obvious at first. So if you're interested in that, I'm just gonna keep going here. Otherwise, if you don't want to see that, you can jump to the next chapter where we're gonna do the sprinkles. I'm gonna call this drips. Maybe I should start with a frame this time, and then I can put some nodes in here. So this is going to be the last thing coming out of here, and then in here we're gonna call this, we're gonna do drips. They're not gonna look like drips, but it's an interesting, you know, it's practice how to use geometry nodes. All right, so first of all, We want to move things down on the C-axis, right? So we have to separate the position of each vertex out into X, Y, and Z components, and then we can work with that C. Of course, there's probably a million other ways to do this, but this is what we're gonna do now. Attribute separate X, Y, Z, and this is where we're plugging in our whatever's coming out of here. And then we have this, and we're gonna separate the position. Let me zoom in so that you can read it in the tutorial. And we separate X, Y, and Z. Okay, so now we have attributes, and now we can work with that C value. First of all, we only want to move things that are on the bottom of our frosting here, right? And if I mute this transform node, what's the bottom? Well, everything below 0. This would be the bottom half, because we're moving the frosting up as the very last step here, right? So everything below 0. Cool, let's do something. Everything, well, let me just hide the dough so we can see this here. I'm gonna need an attribute math node. Put that in here, and if it is less than, what is less than? The C, not T, C. C is less than a float of 0. We're gonna call that bottom. So now we have a new attribute called bottom that we can work with. Okay, now we need another clouds texture. So let's go back to the textures. Frosting displays, copy that, call it frosting drips. Okay, here we probably want more details, or a lower size value, like that. I don't know, play with some values here. You can play with that. And then we need an attribute sample texture node. In here we want the frosting drips. We want, again, we don't have a UV map, so we just take position for the mapping. The result should be, what am I calling this? Let's call it drips. Now at the very end here, of course, we're gonna need an attribute combine node. So let me put that in here right away. So at the end, we're gonna combine X, what is this now? Attribute combine X, Y, Z, yeah, cool. We're gonna combine 3 attributes, the X attribute, the Y attribute. We're not touching X and Y, but we're gonna change the C, and we put that back into the position of each vertex. Now all we need to do is do something here using our drips texture, cloud texture, to change the C attribute. We want to move C down. So we're gonna need an attribute math. We want to subtract from the C a certain value. We could do a float and put it back into the C just to see what's happening. And if we increase that, we're moving all of the things down. We only want to affect the bottom half, like I said, and we want to somehow bring this in. So I'm gonna need another attribute math, multiply the drips, multiply drips. That's not copying. Cool. I have to plug it in like this. We multiply the drips with another attribute, the bottom, right? I hope this works. Copy, paste. Yep. And we can plug that back into drips. So now my cloud texture drips is multiplied by this bottom attribute, which is just the bottom half. So now drips is only affected on the bottom half, but what is on the top? That would be 0. So if you think bottom is true or false, false is 0, true is 1. Multiplying by 0 is going to be 0, so that's not what we want. We want the top half to stay where it is, so we multiply or add nothing basically, and then, or we want to subtract 0 so that the top half stays, and then we want to subtract something from the bottom. And we can do that with an attribute map range node. And we can say, hey, if bottom, where is it? Bottom is 0, which is false, we want it to be 0. And if it's 1, which is true, so on the bottom, we want some factor that we can plug in here then. Cool. And we put that into something, we call it multiplier. And now we just multiply our noise texture drips with that multiplier. And then we subtract from the C an attribute, that multiplier. Okay, well, it's already doing something. We're only moving the bottom half, but it's still not quite not what we want because we're stretching this out now. We can sort of want like an proportional stretch, right? So how do we do that? Well, we want to multiply drips with our C and plug that back into drips. And then, so okay, drips, multiply drips. We multiply drips by C, put that into drips, and then we multiply here by drips. Now, what do we have? Oh, now we have proportional stretching of the bottom half. So, like I said, this is not very straightforward, but we're basically masking out the bottom half of our object. Then we're introducing this noise texture here, or clouds texture. And then we have to do all sorts of mapping here. This is basically mapping the bottom half so that we're only affecting the bottom half used on that Boolean 0 or 1 bottom attribute that we're creating here. And then we just multiply that noise texture, this one here, with that multiplication factor, which is 1 for all of this, so we're not changing it, and then it is something else, this value here, for the bottom half, and then we're multiplying that value with our C so that we get a proportional edit, basically, and we just subtract that from the C. So now this here, this 2 max, is really our stretching of the bottom half. Okay. Now this already looks, it kind of looks like drips because we have this texture here where we can play with the size, so we can get more or less drips like that. Okay. And we're influencing just the C value of that. And then if we switch on the donut, we can see this. Oh, and I also have to unmute this guy. We can see that this is a bit weird. So what do we have to do? First of all, let's look at this from front view. We can see that we're sort of dragging stuff out the bottom, right? So if I drag this all the way down here to get like these drips on the side here, then everything comes out the bottom. We don't want that, so we want to clamp this. Oh wow, it's kind of slowing down now. My viewport is lagging. And how do we clamp this? Well, we don't want the C to go below here. So all we need is, again, another attribute, math node, plug that in here. And we're going to take, how is this, the greater, no, not greater than, the maximum, the bigger one. C or float, and result should be C. And now here we can clamp this so that nothing sticks out the bottom. Cool. How do we do this? Well, maybe like that. And then over here, this is where I'm squishing it. Maybe this is too much. What if we leave it like that? Or just do a little bit like this. Okay. Now, again, remember, I'm not going for realism here. This is not, you know, nice drippy looking thing. This is just to play around with geometry nodes. Maybe a little more like that. Cool. What if we bring this down, squish it like that, Then we can play with this, which is the displacement. Well, it looks a little bit like drips. Okay, awesome. Drips are done. This is our node tree. How can we organize this a little bit better? So we have, this is our final transform to move it up to be on top. And then this is just a little subdivide. We can play with this too, subdivide. Can increase. That doesn't look good. Or decrease. Maybe don't use the subdivide. Yeah, you know what? I'm not gonna use a subdivide. I'm just gonna mute this. So, okay. So here we're squishing it a little bit, the donut. So squishing it this way and making it a little wider so that it sticks out on the sides. Then we have our own displace. We could use the displace modifier, but now you know how to make your own displace modifier. Displacement along the normals, and this here is your displacement strength. Then I'm just, since this displace now inflates everything, I have my deflate here again along the normal with this deflation factor here, which is a vector. And then all of this is just a bunch of nodes playing with the C position of each vertex and modifying that and mapping out just the bottom so that we can pull that down on the C. And then here we're clamping it so that nothing sticks out on the bottom. Maybe we can play with this some more. No, I think this looks pretty good. Okay, so very stylized frosting here, but we're getting to our famous, infamous pink donut tutorial. Cool. So frosting, I think I'm just gonna call this done now. You can see that there is a lot to play with here, and you can play with the subdivisions, and if you play with the subdivisions you might want to change some of the other settings. Alright, now we have dough, we have frosting, we need some sprinkles, and we're gonna look at that in the next part of this tutorial series. I hope you learned something. I hope you enjoy making a donut using geometry nodes. Thank you for watching. Crispy out.